Welcome to this lesson on Kubernetes volume access modes. In Kubernetes storage, access modes are critical settings that determine how pods can interact with persistent volumes. Today, we'll explore the three main access modes: ReadWriteOnce, ReadOnlyMany, and ReadWriteMany. Each mode serves different use cases and has specific restrictions that you need to understand when designing your storage architecture. Access modes define how a volume can be mounted and accessed by pods in a cluster. These modes are specified in both persistent volume and persistent volume claim definitions. They control two important aspects: the read and write permissions, and whether multiple pods can access the volume concurrently. It's important to note that access modes are enforced at the volume level, not at the storage class level. This means each individual volume has its own access mode configuration. Let's start with ReadWriteOnce, abbreviated as RWO. This access mode allows a volume to be mounted as read-write by a single node. The key characteristic here is that only one node can mount the volume at any given time. However, this node gets full read and write permissions. An interesting point to note is that multiple pods running on the same node can actually share access to this volume. So while the volume is restricted to one node, multiple pods on that node can use it simultaneously. ReadWriteOnce is the most commonly used access mode and has several practical applications. It's ideal for databases like MySQL, PostgreSQL, or MongoDB when running single-instance deployments. It's also perfect for persistent logging, where applications running on a single node need to write logs. Additionally, stateful applications like Jenkins or GitLab runners that require exclusive write access benefit from this mode. An important advantage is that ReadWriteOnce is the most widely supported access mode across cloud providers, making it a reliable choice for most workloads. Next, we have ReadOnlyMany, or ROX. This access mode allows a volume to be mounted as read-only by many nodes simultaneously. The distinguishing features are that multiple nodes can mount the volume concurrently, but all access is read-only, meaning no write operations are permitted. This makes it ideal for sharing static data across multiple pods. The data distribution is efficient because multiple pods on different nodes can all read from the same volume at the same time. ReadOnlyMany is particularly useful in several scenarios. For configuration files that need to be shared across multiple pods, this mode ensures consistent configuration data distribution. For static assets like images, CSS files, or JavaScript files that are served by multiple web servers, ReadOnlyMany provides an efficient way to share these resources. It's also excellent for reference data such as machine learning models, lookup tables, or datasets used by analytics pods. One critical point to remember: the data must be written externally or by a separate process before mounting, since the volume itself is read only when mounted by the consuming pods. Finally, let's discuss ReadWriteMany, abbreviated as RWX. This is the most permissive access mode, allowing a volume to be mounted as read-write by many nodes simultaneously. Multiple nodes can mount and write to the volume concurrently, and all pods get full read and write permissions. However, this mode has an important requirement: it needs shared file system support. This typically means using distributed file systems like NFS, CephFS, or GlusterFS. Not all storage providers support this mode, so you'll need to verify compatibility with your infrastructure.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.